So my advice has been that you should rely on the fundamental tools of counting rather than getting caught up with memorizing a bunch of different techniques in a bunch of different specific situations. But here is one technique that I think you should remember because it is very frequently useful and it is hard to get by without it. So this is called stars and bars. And I think it goes by many other names. But this is the name that I learned it by. So this is the case of, before we were doing distinguishable balls and distinguishable boxes. And now we are going to talk about indistinguishable balls and distinguishable boxes. So, for example, how many ways are there to choose 4 pieces of fruit from a bowl containing apples? Let me rewrite that. That is supposed to say oranges and pears. So the point is that we are considering all of the apples to be basically the same. We don't care which apples we're taking, but we do care how many apples we're taking versus how many oranges and how many pears. So again, the balls and boxes in this case are not absolutely straightforward, but it's going to be similar to this thing that we've seen before, where the balls are slots and the boxes are basically what thing we are putting in the slots. So it's almost a little bit reversed from balls and boxes, but we call it balls and boxes just to have a uniform way of talking about these things. So the balls are the 4 spaces on your plate. And we don't care, we're not choosing the fruit in some kind of order. We're not arranging it in any way. So the 4 spaces that we have for fruits are indistinguishable. The boxes are apples, oranges, and pears. These are distinguishable. So again, it's very much like the Mississippi example that we did. The difference is that in the Mississippi example, the balls were slots, but we had them in a specific order. So they were distinguishable because the order mattered there. Here, the order does not matter, so our balls are indistinguishable. And here is your one trick that you should remember beyond the fundamentals. We draw a diagram like so. Something like this. So, as you can see, it consists of stars and bars. And how we're interpreting this is, this means we choose 2 apples. This means we choose 1 orange. And this means we choose 1 pear. Or, for example, 1 orange and 3 pears, what would this look like? So how are we drawing this? We have 2 bars, and the stars that come before the first bar correspond to apples. And then in between the 2 bars corresponds to oranges, and at the end corresponds to pears. So 1 orange and 3 pears would mean no apples, 1 orange, 3 pears. And for example, what would be 3 apples, 1 pear? It would be like, let's see, 3 apples go in the first slot, no oranges, and then 1 pear. So the significance of this trick is we've rephrased the question how many rearrangements of, let's see, we have 4 stars and 2 bars. And just like Mississippi, there are, let's see, so six characters total. And then we have a group of 4 and a group of 2. So let me actually erase this because the counting philosophy is just like Mississippi. But the general rule is slightly different. What is the general rule? Or, you know, we've translated it into that situation. But let's come back to our current situation and come up with a general rule. To put k indistinguishable balls in n distinguishable boxes, the number of ways to do this is n plus k minus 1, choose k. Because, so let's take a minute to interpret this. N plus k minus 1 is the total number of symbols. That's because the number of symbols is, first of all, the number of balls. We have 1 star for each ball. But the number of boxes, we have 1 less bar than we have boxes, right? Because 2 bars will make 3 boxes for us. So that is where the minus 1 comes from. So this is the total number of symbols of these guys. And then choose k just means choose which positions to put the stars in. That's another way of thinking about how many ways do you rearrange these things. So indistinguishable balls and distinguishable boxes is stars and bars. And you can think about it, well, by translating it into this situation and then using your fundamental counting principles. So finally, what about indistinguishable boxes? So we've gone over the 2 cases where you have distinguishable boxes. What if you have indistinguishable boxes? So I have not prepared any examples of this because you're basically screwed. So in this case, in these cases, there are not such good strategies. I mean, somehow it seems like the problems are just harder. And so often, it is best to, maybe there's some ad hoc method you can use, or you can just write out all the possibilities. Which does not sound very appealing, but at least as far as this course is concerned, you can rest assured that I will not spend a lot of time making you do that, because I don't want to do that either. So, here are all of your excellent tools to count things.